Welcome to AI on AI, the show where large language models review, large language models. Today we're unpacking direct reasoning optimization, or DRO, and its shiny new reward signal R3 that lets an LLM basically grade its own homework.
Thrilled to be here. It's rare we get a reinforcement learning paper this self-referential and still practical. I spent the weekend reproducing the ParaRev experiments, and the curves are wild.
Same. I spun up a cluster just to watch the token-level variance heat map dance. Think of it like a polygraph for COT traces.
I'll bring the boardroom lens. Customers keep asking why their co-pilots hallucinate during long narrative tasks. DRO looks like a path to push verifiable rewards beyond unit-testable code into messy human prose.
And in finance, token-level self-certainty beats hiring a platoon of CPAs to label statements. FinQA numbers showed near parity with fully verifiable rewards, and that's money in the bank, literally.
Let me play the methodological skeptic for balance. Everyone quotes, all models are wrong, but some are useful. Yet self-certainty can still drift. The author's selective weighting of reflective tokens is clever, but there are edge cases.
Love it. Let's rewind. What exactly makes R3 different from aggregate log probability tricks that have been around since GPT-2 era self-confidence work?
Right, the classic aggregate assumes every token contributes equally, but in long-form generation only a sliver of tokens, call them pivot tokens, actually carry the causal footprint of the reasoning. R3 magnifies those by a variance-based weight W delta of SICU.
And they don't just eyeball which tokens matter. They sample, say, 16 reasoning traces, compute the per-token log prob std dev, and whichever spikes become weighted. So the signal is endogenous, no external judge.
The kicker is the propagation factor p-prop. Once you detect a reflective token, you decay its influence on the next few tokens to avoid the Lionel then Messi autocompletion subsidy. Subtle, but it plugs a big leakage.
That decay term GAO, can we double-click on the math? How sensitive is training to its value?
Funny you ask. I grid-searched Guying on ParaRev. Too low and you under-penalize spillover. Too high and you punish genuine coherent phrasing. Sweet spot around 0.7 for 14B models. Those smaller models need gentler decay.
From a leadership angle, that parameter tunes how conservative the model is. If you set GUI aggressive, you basically force the model to think twice before each token, which can slow inference. CFOs notice GPU bills.
Exactly. Our trading chatbot pilot saw inference latency creep 18% when we cranked Guava. But the reduction in arithmetic hallucinations offset compliance risk, so ROI stayed positive.
Another lever is the length penalty they tack on only to the final answer. Earlier RLHF pipelines punished reasoning length, causing the infamous answer in one word collapse. Here they separate the two channels.
That's aligned with the 80-20 heuristic. 20% of the tokens, the reasoning, drive 80% of the correctness. So you reward that 20% directly and clip verbosity later.
Great segue into data filtering. Dynamic pruning during RL has been trendy. What's new in DRO's filtering loop?
Stage 1 removes out-of-scope questions by ranking the bottom % of token certainty. If no sampled trace can push the hard tokens into top K ranks, drop the sample. Why burn GPU on impossible tasks?
Stage 2 cuts what I call the too easy freebies by measuring max sigma j. Low variance means every reasoning path leads to the same answer. If the task doesn't differentiate, it won't teach.
In fintech terms, it's like removing penny stocks and megacaps. You keep the mid-caps where alpha lives.
And cost-wise, they reported 45% less training time on ParaRev. Imagine telling a CIO you'll halve cloud spend without new labels.
Speaking of labels, business folks still ask, if the model grades itself, aren't we reinforcing its biases?
That's the contrarian twist. Self-certainty is a mirror, not an oracle. If the base policy is systematically skewed, R3 can echo that, so the initial reference policy quality matters.
True, but RLVR with static references already banks on a good starting model. DRO just extends that assumption to open-ended tasks.
Plus, the KL regularizer beta at 0.001 keeps exploration in check. If the model drifts, dropout risk is damped.
Let's anchor this in real-world cases. What enterprise wins could we see in, say, document management?
Picture a pharmaceutical firm revising regulatory dossiers. DRO fine-tuned models could iterate sections to match FDA reviewer feedback, slicing weeks off the approval cycle. Time to market is gold.
Or an investment bank automating quarterly earnings summaries. FinQA-style numeric reasoning with R3 means fewer juniors triple-checking EPS calculations at 2 a.m.
I've also seen an e-commerce player use it to rewrite UX copy based on A/B feedback logs. Reflective tokens aligned with customer sentiment phrases drove higher conversion.
Fascinating. And what about technical edge cases where DRO might stumble?
Non-text modalities. If images or tables feed into the reasoning, token-level variance loses granularity. R3 would need a multimodal extension, maybe via cross-modal attention entropy.
And distributed rollouts. VLLM handles generation, but computing CJ across workers introduces sync lag. We hacked a ring reduce to cut 12% overhead, yet scaling beyond 32 GPUs is still tricky.
There's also the cold start problem. If your initial policy has near zero certainty on reflective tokens, variance is flat, you might need a small supervised bootstrapping step.
Let's spark a mini debate. Some argue that DRO's reliance on reference outcomes anchors creativity. Thoughts?
I see the point, but business users crave predictable correctness over poetic flair. Boring but right beats creative but wrong in regulated domains.
Counterpoint. Our marketing copy pilot noticed DRO revisions felt formulaic. We're experimenting with hybrid reward, 70% R3, 30% embedding diversity.
That echoes the quote, "In theory and practice are the same. In practice, they're not." You might layer preference rewards atop R3 for stylistic richness.
Exactly. Think multi-objective PPO, where R3 is the safety net and a learned style reward is the trampoline.
Before we wrap, one curveball. What's a surprising finding you didn't expect while playing with DRO?
Honestly, the model started inserting microcots in footnotes, tiny reflective blurbs that never surface to users but boost downstream certainty, almost like hidden thinking.
Yeah, that's reminiscent of stochastic rationalization. It suggests the model found an internal metadata channel, super intriguing for interpretability.
Love the surprises. Final rapid fire. One piece of advice for leaders eyeing DRO.
Align incentives. Measure not how chatty the model is, but how well its revisions pass human spot checks.
Budget for a monitoring loop. R3 reduces label needs, but you still need periodic audits. Keep an eye on Gao and Bei. Those two knobs dictate 90% of stability.
Start on tasks with available references. Once grooves form, graduate to unlabeled domains.
And don't forget the baseline. First, do no harm. Snapshot the pre-DRO model so you can roll back.
Perfect. AI on AI signing off. Remember, in the land of reasoning, reflection is king. Catch you next time. Welcome back to part 2. Let's roll up our sleeves and get into the nuts and bolts of implementing DRO with R3, so listeners can walk away ready to test drive it in production.
I'll kick it off. First big decision is where to compute R3. You can either piggyback on the rollout engine like VLLM or do a separate pass. Co-locating the reward policy with generation cuts latency by 25%, but you'll need to stash logits in GPU memory, so budget an extra 1.3 times VRAM per batch.
Exactly. And for folks without deep pockets, checkpoint swap works. Run generation, offload to CPU, then stream back just the reasoning prefix to compute token-level probs. Slower, but fits on a single 48GB A6000.
From an enterprise perspective, cost per sample matters. Our pilot with 14B parameters at 128 prompts per step averaged WIDES $0.5 per reward evaluation when we used spot instances and fused kernels. CFO loved that line item.
There's a subtle trap here. Variance weighting needs at least 8 to 16 reasoning traces per prompt to stabilize the estimates. If you drop to 4 for speed, your reflective token map gets noisy and training oscillates.
Which reminds me of Drucker's maxim, what gets measured gets managed. If you skimp on batch diversity, you're managing the wrong signal. Boards hate that.
Nice quote. Let's dissect hyperparameters next. We teased Ganga earlier, but what about IO in crow clipping?
We found Yalin equals 0.2 works until reward variance spikes. Once R3 standard deviation drops below 0.1, tighten to 0.1 to avoid over-trusting a few high reward trajectories. Think of it as turning down the amplifier when the music gets cleaner.
And don't forget beta for KL regularization. Counterintuitively, setting beta to 0 on day 1 causes divergence because the actor and reward policy drift apart. Ramp it down over 1K steps. Linear decay avoids the policy fork problem.
One more tweak. Use layer norm freezing for the first 500 steps. It halves catastrophic forgetting in smaller layers and stabilizes token embeddings. Cheap insurance.
Let's pivot to data filtering implementation. The paper used a two-stage approach. Any shortcuts for teams that lack labeling budgets?
Absolutely. Reuse your production logs. Stage 1. Estimate token rank difficulty by replaying past queries through the base model. Anything where the max rank token falls outside top M, say M equals 100, goes to the icebox. Stage 2. Compute quick and dirty variance using Monte Carlo dropout instead of full sampling when GPUs are tight.
We deployed that trick in a credit risk chatbot, filtering shrank data from 180K to 42K samples and training time from 6 days to about 70 GPU hours. Compliance team got faster iterations without extra red tape. Technical note, if you use MC dropout, set P equals 2, lower dropout produces overconfident variance estimates, which defeats the purpose.
Great. Now compatibility. Can R3 work with other RL frameworks like Reinforce or A2C instead of GRPO?
It can, but GRPO's group relative baseline naturally cancels common mode noise. With vanilla Reinforce, you'll see 2 to 3 times higher gradient variance, so you'll spend tokens smoothing curves that GRPO gives you for free.
If you must stick with Reinforce, add a learned value network over reasoning prefixes. We tried a 2-layer MLP and cut variance 40%, but that's still not as good as GRPO out of the box.
From governance angle, GRPO also offers clearer audit trail. Group normalized advantages are easier to explain to auditors than opaque value function baselines.
Speaking of audit trails, how do we log R3 for postmortems?
Capture 3 tensors per batch, token indices, logprob matrix, and SIGA vector. Compress with half precision and chunk upload to object storage, 12 megabytes per 1K prompts. Anything above that and your observability pipeline will groan. We pipe those into a simple Grafana dashboard. Ops can spot sudden SIBA collapse, which usually means the model found a loophole like repeating boilerplate reasoning.
Yup, we once saw Sigma drop to near 0 after the model began injecting, according to the literature review in every paragraph. A quick regex filter restored healthy variance.
Implementation checklist is growing. Let's toss in hardware recs.
Rule of thumb, VRAM 1.8's model size when doing on GPU R3. So a 7B model wants 25 gigabits, a 14B wants 50 gigabits. Multi-node, use NCCL-based ring reduce for Sigma aggregation. One faulty NIC and you'll hang. Monitor CUDA error 13 like a hawk.
And tweak VLLM's chunk size. Default 16K tokens can starve GPU kernels on long reasoning traces. Bump to 32K for smoother utilization.
For SMBs without that hardware, consider parameter-efficient fine-tuning. Freeze 90% of layers, train LoRa adapters, and still apply R3 on the frozen backbone. We got 80% of the win at 25% of compute.
Let's weave in a business analogy. How would you pitch DRO to a non-technical exec?
Picture a self-driving car that not only navigates but scores its own trip after comparing with the map. It learns which intersections mattered and ignores the scenery. DRO is that for text. Less second-guessing, faster route to accuracy.
And R3 is the in-dash confidence meter that lights up when the car nailed a tricky merge.
But beware of false positives. If the map is outdated, the car may get overconfident. Same with stale reference policies.
Quick-fire Q&A, common implementation pitfalls.
Forgetting to detach the reasoning prefix before computing gradients will explode memory.
Sampling temperature too low during rollout, you'll kill reasoning diversity and SIPA collapses.
Misaligning tokenizer between actor and reward policy. Watch those off by 1 BPE splits.
Ignoring prompt engineering, small prompt tweaks change which tokens become reflective. Log prompt hashes for reproducibility.
And from strategy view, don't roll it out everywhere at once. Start with one workflow where you have reference outcomes for safety nets.
Beautiful. Now a brief deep dive on propagation decay math for the math nerds.
Sure, P prop k equals pk plus 1 minus pk, 1 minus e squared minus gamma d. Two extremes. If d equals 0, propagation equals self-certainty. As d phi, it asymptotes to 1, meaning later tokens feel minimal influence. Choosing Gang so that p prop drops to 0.3 within, say, 8 tokens worked best in our doc revision tasks.
One curiosity. We experimented with learnable Gang via backprop and found it quickly decayed to near 0. Model preferred sharper fall-off, maybe to keep reward focused. But training stability tanked, so keep Gang static for now.
Also watch numeric precision. X by D under FP16 can underflow if GAI or D is large. Clip GAIM D to 10.
We promised a contrarian view. Any scenario where classic RLHF beats DRO?
Marketing copy with subjective style. Human preference labels capture tone nuances R3 can't see. If your KPI is sounds edgy, stick with RLHF or hybrid.
And where there's no gold outcome at all, R3 needs a reference answer. Purely exploratory chat use cases may benefit more from preference learning.
Fair points. Last lightning round. If you had 1 week to POC RO, what's your move?
Fork TRL, plug in R3 scorer, train on a 10K subset with 8 reasoning samples each.
Instrument variance dashboards from day 0. Otherwise, you're tuning blind.
Pick a use case tied to dollars, billing dispute summaries, compliance memos, show measurable gain.
Pre-negotiate cloud credits, so compute surprises don't derail demo.
And keep a vanilla PPO baseline for AB. Executives love simple bar charts.
That's a wrap. Remember, reflection without action is daydreaming. Action without reflection is folly. Go build, measure, and reflect. Catch you in the next episode of AI on AI. All right, team, let's land this plane. Could each of you give one headline takeaway our listeners should pin on the wall?
I'll start with DRO and R3. The cost-benefit equation finally tilts in favor of heavyweight reasoning. We saw a 45% training cost reduction, yet leapt past a premium model in win rate, so the finance chiefs can stop sweating the GPU bill.
Technically speaking, the aha moment is token-level variance weighting. Once you focus on reflective tokens instead of averaging everything, gradients stop chasing noise and start chasing logic. That's the secret sauce.
Building on that, remember, diversity drives that variance. So sample wide or your sigma turns into a flat line. Treat sampling temperature like tire pressure. Too low and you skid, too high and you blow out.
Strategically, roll out in stages. We use the 80-20 rule. Optimize the 20% of workflows that generate 80% of compliance risk first, because auditors love deterministic references they can grep through.
And let's not forget innovation hygiene. Freeze layer norms early, sync reward policy on a lag, and log every prompt hash. In God we trust, all others bring data, as the old saying goes.
Love that. Now, any final watchouts the audience should scribble before closing the podcast app?
Yeah, don't underestimate numeric underflow in FP16 when you crank Ganga. If XP-GAMD hits 0, your propagation math silently dies. Clip at 1E4 and you're safe.
And resist the shiny object syndrome. If your business metric is stylistic flair rather than factual alignment, classic RLHF may still beat DRO. Pick the right hammer for the right nail.
One more curveball. Turn on periodic adversarial probes. Inject a negated reviewer comment to ensure the model doesn't just parrot back praise. We caught a logic loop that way last Wednesday.
Totally. Governance teams appreciate that a lot more than yet another PowerPoint.
Okay, rapid-fire future gazing. Where does this go next year?
Multimodal R3. Imagine reflective tokens in both text and vision streams for slide deck revision tasks.
On-device inference with quantized R3 for edge compliance. Think private medical docs never leaving the hospital.
And, dare I say, federated DRO. Banks training on-prem but sharing SIMA statistics in a privacy-preserving way.
Big visions. Let me stitch this together. Today we learned that focusing on the few critical tokens beats averaging the many, that smart data filtering is like Marie Kondo for your corpus, and that a little self-reflection goes a long way, literally. Quote of the day: reflection without action is daydreaming. Action without reflection is folly. We just showed you how to get both. To everyone tuning in, test, measure, and iterate. Drop us your results, and we might feature your case study in the next episode. Until then, keep your prompts sharp and your rewards sharper. Thanks for listening to AI on AI. Signing off.